Hello, night travelers, those quiet souls who wander beneath the stars, seeking calm within the gentle symphony of the night. Welcome back to the Night Observer, a place where minds may rest, where thoughts slow down, and where sleep comes softly as we drift together toward the vast and mysterious universe. I have lit a fire. Once again, we gather around its warmth, listening to an ancient story, the story of the cosmos itself. Tonight, we will lift our gaze toward the sky and allow ourselves to dissolve into its immensity. Close your eyes. Find a position of comfort. Let your body sink into the stillness around you. Allow your breath to settle into its most natural rhythm, slow and steady, like distant waves touching a quiet shore. There is no hurry here. On this journey, we have all the time the universe can offer. Tonight, I will tell you a story about what we call time, a profound mystery that began 13.8 billion years ago and continues silently and patiently to weave the fabric of reality upon which you now rest. Whispers from the past, when mythology first spoke of time. Long before clocks and calendars, when humans first gazed upward into the night, they noticed the stars moving in endless cycles. To the ancient Babylonians, time was not a number, but part of a sacred struggle. They believed the Milky Way itself was formed from the severed tail of the sea dragon Tiamat, a relic of primordial creation placed among the heavens. In the East, ancient Indian philosophers imagined time as a vast wheel, the Kalachakra. They envisioned a universe without a final end, moving through immense cycles of birth, existence, and dissolution, lasting up to 4.32 billion years. In this view, death was never final, but merely the quiet beginning of renewal. The Greeks, too, gave time a human face. They spoke of Kronos, the god of measurable time, the time of clocks and calendars. But they also revered Kairos, the god of the fleeting, precious moment, the one chance that cannot be captured or repeated. Even then, humanity understood that time was both objective and deeply personal. Later, the rise of Abrahamic traditions such as Christianity and Islam reshaped this vision. Time became a straight path, beginning with divine creation and moving toward an irreversible end. St. Augustine reflected deeply on this mystery, leaving us with words that still echo through the centuries. What is time? If no one asks me, I know. If I wish to explain it, I do not. For him, time lived within the human mind, through memory of the past, awareness of the present, and expectation of the future. The giants debate: is time a container or a relationship? Now imagine the 17th century, a dim room filled with books, candlelight, and early telescopes. Two towering minds stand on opposite sides of a profound question. Sir Isaac Newton believed time was absolute. To him, time flowed like the eternal clock of God, existing independently of the universe itself. Even if all matter vanished, time would continue, cold and unchanging. Space and time, in his view, were vast, empty containers. His famous spinning bucket experiment seemed to support this idea. Motion, he argued, must be measured against an absolute background. Across from him stood Gottfried Wilhelm Leibniz, who firmly disagreed. For Leibniz, time was not a thing at all, but a relationship between events. Without change, without events, time had no meaning. Time existed only as before and after, much like family relationships exist only because people do. This debate lingered unresolved until the 18th century, when Immanuel Kant offered a radical insight. Time, he suggested, does not belong to the external world. It belongs to us. It is an a priori structure of the mind, a lens through which all experience is organized. Without time, our perceptions would be nothing more than scattered sensations, lacking coherence or order. The Einstein Revolution, when time learned to bend. Now, let us step into a modest patent office in Switzerland in the year 1905. A young man named Albert Einstein watches the hands of a clock and quietly overturns centuries of belief. Einstein realized that time is not absolute. It stretches and contracts depending on motion and gravity. Space and time are not separate entities, but fused into a single four-dimensional structure known as space-time. If a train moves near the speed of light, a clock aboard that train will tick more slowly than one on the platform. This is not an illusion. It is reality itself. Time dilation is woven into the universe. Gravity, too, alters time. A clock closer to a massive object runs more slowly than one farther away. Near a black hole, time nearly comes to a halt. Even astronauts aboard the International Space Station age slightly more slowly than we do here on Earth. The arrow of time and the quiet rise of chaos. Why do we grow older but never younger? Why does a shattered glass never reassemble itself? The answer lies in entropy, the measure of disorder. The second law of thermodynamics tells us that the universe naturally moves from order toward chaos. Because the universe began in an extraordinarily ordered state at the Big Bang, time has a direction, an arrow that always points forward. Some physicists have taken this idea even further, proposing the concept of a block universe. In this view, past, present, and future all exist simultaneously, like a completed book. The sense of time flowing may be nothing more than a feature of human consciousness. Time and the grand story of the cosmos. Our universe is approximately 13.8 billion years old. Time itself began with the Big Bang. Before that moment, even the word "before" may have had no meaning. Time has been a great creator. It allowed energy to become matter, stars to ignite after the long cosmic darkness, and galaxies to grow and collide. It will one day bring the Milky Way and Andromeda together in a slow, silent dance billions of years from now. Yet time is also a gentle destroyer. As dark energy drives the universe's expansion ever faster, stars will fade, black holes will evaporate, and entropy will reach its peak. When nothing remains to change, time itself may lose all meaning, and the universe will rest in a quiet thermal stillness. Whether we see time as a god, a mental framework, or a flexible dimension, it remains a gift. It gives meaning to memory, purpose to action, and value to our fleeting existence. And now, as the stars continue their ancient rhythms far beyond our understanding, let your thoughts soften. The universe moves on, quietly and patiently, and for this moment, you are here, safe, aware, and held within the gentle flow of time. You have already encountered your first ideas about time, dear night travelers. Tonight, I invite you to listen to a story about how a quiet young man, working behind a desk in a modest patent office, gently lifted the veil of reality and forever changed the way humanity understands time itself. Our journey begins with an old belief, one that lulled generations into a sense of certainty, a belief so familiar that it felt unquestionable. Newton's universal clock and the illusion of the absolute. Long before Albert Einstein, humanity inhabited a universe governed by a stern and unyielding master. Time was seen as supreme, cold, and eternal. Sir Isaac Newton, the great architect of classical physics, imagined the universe as a vast stage upon which events unfolded, while time marched forward like a perfect universal clock. In Newton's world, a second on Earth was identical to a second on the farthest star. Time flowed evenly, like a calm and unwavering river. Whether one stood still or raced through the air, everyone shared the same rhythm, the same cosmic heartbeat. It was a comforting vision, simple, logical, and deeply reassuring. Yet beneath that calm surface, subtle cracks were already forming. In the mid-19th century, James Clerk Maxwell revealed that light is a wave. one that travels at a fixed and constant speed. This discovery unsettled the foundations of Newton's universe. If light always moves at the same speed, regardless of the observer, how could that fit within a world where motion depends on perspective? Scientists searched for answers in an invisible substance they called the ether, a universal medium through which light was thought to travel. But in 1887, the famous Michelson-Morley experiment found nothing at all. The ether, it seemed, was only a shadow. And then, quietly, Albert Einstein entered the story, unburdened by old assumptions. A young man in Bern and a thought of light. Picture an afternoon in 1905 in the city of Bern, Switzerland. A young patent clerk named Albert Einstein gazes out of his office window. His eyes drift not toward machines or diagrams, but toward the clock atop a distant bell tower. A question forms in his mind, simple yet profound. What would happen if I could ride alongside a beam of light? If I moved at the speed of light, would that beam appear frozen beside me? The answer he reached was astonishing in its clarity. The speed of light, Einstein realized, is absolute. No matter how fast you move, whether standing still or racing aboard a speeding train, light always travels at the same pace, roughly 300,000 kilometers per second. But such certainty demanded a sacrifice. If light could not change, then time must. Time, Einstein understood, was not rigid. It was flexible, elastic. When time begins to move. In the quiet darkness, allow your imagination to follow one of Einstein's most elegant ideas, the light clock. Picture a spacecraft moving at extraordinary speed. Inside it, a beam of light bounces steadily between two mirrors. To the traveler aboard the ship, the light moves simply up and down, marking time with each reflection. But to an observer standing still, watching the ship pass by, that same beam traces a longer, slanted path through space. Because light's speed never changes, the only possible conclusion is this: the clock on the moving ship must tick more slowly. This is time dilation. Rest for a moment with that thought. Time is no longer a shared rhythm. It becomes personal. The faster you move through space, the more slowly you move through time. This is not theory alone. In 1971, atomic clocks flown around the Earth returned running slightly behind those left on the ground. Even the GPS satellites guiding us each day must constantly correct their clocks, for time flows differently high above the Earth than it does beneath our feet. The birth of space-time. Still, the story continued to unfold. In 1908, Einstein's former teacher, Hermann Minkowski, offered a vision both simple and profound. Space and time, he said, are not separate entities at all. They are woven together into a single fabric, space-time. Imagine this fabric as a vast, delicate tapestry. Every moment of your life, your first breath, your quiet reflections tonight, exists as a point upon it, defined not only by where you are, but by when you are. We do not merely exist in space and in time, we are part of their union. When gravity slows the clock. Einstein was not finished. For 10 more years, he wrestled with the nature of gravity, until in 1915, he revealed the general theory of relativity, a theory not of forces, but of geometry. Space-time, Einstein showed, is not rigid. It can bend. Massive objects, like stars and planets, curve it, much as a heavy sphere bends a stretched cloth. What we experience as gravity is simply motion along these curved paths. And here lies one of the universe's quietest wonders. Gravity slows time. A clock closer to the Earth's core ticks more slowly than one higher above. Near a black hole, where space-time is twisted to its extreme, time itself appears to come to a standstill. To a distant observer, someone falling toward a black hole would seem to slow endlessly, frozen at the edge of eternity. A universe without a single. Now. From these insights arose a deeply unsettling idea: the block universe. In Einstein's cosmos, there is no universal present. Past, present, and future coexist, equally real. What you call now may already belong to the past for someone else, moving differently through space-time. Einstein once wrote, after the death of his dear friend Michel Besso, that for those who understand physics, the distinction between past, present, and future is only a persistent illusion. Imagine time as a finished book, every page already written. We do not turn the pages. Our consciousness simply becomes aware of one page at a time, the one-way path of chaos. And yet, if all moments exist, why do we move only forward? The answer lies in entropy, the quiet, relentless rise of disorder. While most physical laws work equally well forward or backward in time, the second law of thermodynamics does not. It tells us that chaos always increases. An egg may fall and shatter, but it will never reassemble itself. The universe began in a state of remarkable order, and from that beginning, the arrow of time was set in motion. Now, let these thoughts soften and drift into the night. Time is not a harsh master urging us onward. It is the gentle fabric that holds your memories, your breath, your being. The past is not gone, the future not absent. They are all present within the vast architecture of the universe. There is no need to hurry. Beyond this moment, galaxies continue their silent journey, floating along the tranquil currents of space-time. And here, now, you may let your breathing slow, allowing yourself to merge with that timeless rhythm. Imagine drifting among the stars, where clocks fall silent, and only the soft glow of distant galaxies remains, steady, eternal, and at peace. Albert Einstein offered humanity a new way of seeing time. Through his profound insights, we came to understand that time is not merely a number ticking across a clock face, but an invisible thread, quietly weaving the fabric of reality, from the most distant galaxies to every living cell that breathes within your body. Tonight, our journey moves through three realms of space and time: the immense history of the universe, the slow and graceful rotation of the Milky Way, and finally, the gentle, intimate rhythm of human life. Allow your thoughts to drift naturally along these currents. The chronology of the universe, when time became the great builder. Every story has a beginning. Ours begins approximately 13.8 billion years ago, with an event we call the Big Bang. Yet this was not an explosion within space. It was the moment when space itself, and time along with it, came into existence. Before that instant, the idea of before may have held no meaning at all, because time had not yet been defined. The universe emerged from an unimaginably small, hot, and dense singularity, where the laws of physics as we know them dissolved into silence. In the very first instance of reality, there was the Planck era, a span of time so brief it defies intuition, lasting only the first 10 to the power of minus 43 seconds. During this moment, the universe existed as a unified sea of energy, with gravity equal in strength to the other fundamental forces. Then came inflation, a sudden and extraordinary expansion that occurred before the universe was even 10 to the power of minus 32 seconds old. In that fleeting instant, space itself stretched faster than the speed of light, transforming something microscopic into something vast. Time became the quiet measure of this tremendous growth. As the universe continued to cool, new structures slowly emerged. When it was between 2 and 20 minutes old, nuclear processes formed the first simple elements, hydrogen and helium. Yet it took much longer, nearly 380,000 years, before the universe cooled enough for electrons and atomic nuclei to unite into stable atoms. This marked a turning point. The universe, once opaque and fog-like, suddenly became transparent. Light was finally free to travel unhindered through space. That ancient glow still surrounds us today, as the cosmic microwave background, an echo from the universe's infancy. Even the faint static on an old analog television contains a whisper of this first light. What followed were the Dark Ages, a long and silent era lasting hundreds of millions of years when no stars yet shone. Time flowed quietly through the darkness until, roughly 100 to 300 million years after the Big Bang, the first generation of stars ignited, bathing the universe in light once more. The universe has never stood still. It continues to expand. And because light takes time to travel, every distant galaxy we observe is a glimpse into the past. In this way, the universe itself becomes a vast time machine, revealing moments that unfolded billions of years ago. The Milky Way's rotation, the loops of eternity. Now let your perspective gently narrow, drawing closer to home, to the Milky Way. This immense spiral galaxy contains between 100 and 400 billion stars, bound together in a slow and graceful cosmic dance. Within the Milky Way, time reveals itself through rotation and transformation. The galaxy's oldest stars formed soon after the Dark Ages, nearly as ancient as the universe itself. The thin disk where our sun resides began to take shape about 8.8 billion years ago. Like a living organism, the Milky Way has grown over time, absorbing smaller galaxies and drawing in streams of gas from its surroundings. On Earth, we mark time by the orbit of our planet around the sun. But the sun itself, along with its planets, is moving, circling the center of the Milky Way. One complete journey takes approximately 225 to 240 million years. This vast span is known as a galactic year. Since its birth, the sun has completed only about 20 such orbits. Since the dawn of human civilization, we have experienced merely a fraction, less than 1,000th, of a single galactic rotation. In the calendar of the stars, all of human history occupies only a fleeting moment. Time within the Milky Way is not uniform. Near its center lies Sagittarius A+, a supermassive black hole with a mass millions of times greater than our sun. Its intense gravity bends space-time itself. In such a place, time would pass far more slowly than it does at the galaxy's outer regions. An hour near that center could correspond to decades on Earth. And even our galaxy is not alone or at rest. The Milky Way is moving through space and will, in several billion years, merge with the neighboring Andromeda galaxy, a reminder that time unfolds on scales far beyond a human lifetime. Time in life, the quiet pulse of consciousness. Now gently return your awareness to this room, to your resting body. Time is no longer measured in billions of years, but in seconds, minutes, and subtle inner sensations. Every living organism carries a biological clock. In humans, the circadian rhythm, guided by a small cluster of cells deep within the brain, keeps time over a cycle of roughly 24 hours. It guides your body into sleep and gently prepares you to awaken with the coming dawn. The present moment, however, is not as brief as it seems. In physics, an event has no duration, but in the human mind, the experience of now spans approximately 2 to 3 seconds. Your brain gathers sensory information into these small windows, stitching them together into a continuous flow of awareness, much like frames in a film. Even then, perception lags behind reality. Signals from your senses take time to reach the brain. What you experience as now is actually a record of events that occurred a fraction of a second ago. Time also bends under emotion. In moments of fear or danger, the brain records experiences more intensely. When recalled, these moments appear to unfold in slow motion, even though they passed quickly in real time. As we grow older, time seems to accelerate. Each passing year becomes a smaller fraction of the life already lived. What once felt endless gradually begins to feel fleeting. The meaning of flow, where humanity meets the universe. Now, As your breathing deepens and steadies, consider the connection revealed through time. You are made of stardust. The atoms in your body were forged in the hearts of stars that lived and died billions of years ago. Time allowed those elements to travel across space and come together, here, now, as you. Each life traces a unique path through four-dimensional space-time, a world line that begins as scattered matter, gathers into consciousness, and one day disperses again. Yet within the structure of the universe, every moment you have ever lived continues to exist. The universe continues to expand. Entropy continues its quiet rise. Stars continue their slow, ancient rhythms. And there is no need to fear time's passage. We have traveled together through humanity's first intuitions, lifted the veil on Einstein's vision of reality, and witnessed time at work, from the smallest living cell to the most distant galaxies. Now, in this final chapter, I invite you to listen to the ultimate meaning of time itself, the last quiet whispers as the universe approaches its own twilight. This journey will carry you farther than any telescope can reach, into a future where even stars become memories. There is no need to hurry. In that distant realm, time will no longer serve as a measure, but will stand alone as a solemn and enduring epic. Time, the great storyteller of nothingness. Our universe is not a still image. It is a story, one with a beginning, a rise, and an ending. The first and deepest meaning of time is simple, yet profound. It allows change to exist. Without time, the universe would be frozen in a single instant, without motion, without life, and without consciousness to witness it. Everything began some 13.8 billion years ago in an unimaginably hot and dense singularity. That was the moment when space and time were born together. Before it, even the idea of before had no meaning, because time itself did not yet exist. From that instant onward, time became a silent builder. It allowed energy to condense, fundamental forces to separate, and the first structure of reality to emerge during the Planck era. Time created distance, preventing matter and antimatter from completely annihilating one another, and in doing so, allowed existence itself to endure. Had time stopped there, the universe would have remained an eternal ocean of fire. But time continued, patiently flowing onward. In that flow, clouds of hydrogen and helium were given enough opportunity to gather under gravity's pull, igniting the first stars that pierced the darkness of the cosmic night. Time wove order from chaos, shaping galaxies, star systems, and eventually, a small, quiet solar system capable of sustaining life. Einstein's lens and freedom from absolutes. As we listen more closely to the universe, Albert Einstein reminds us that time is not a rigid tyrant ruling all things equally. In his vision, the deepest meaning of time lies in its relativity and flexibility. Time does not stand apart from space. It merges with it, forming a four-dimensional fabric known as space-time. Imagine time as a soft ribbon of silk, responsive and pliant, shaped by mass and energy. Gravity, then, is not merely a force pulling objects together. It is the bending of time itself. Near black holes, time stretches so dramatically that it nearly comes to rest. This reveals a quiet truth. Each of us inhabits a unique timeline. The faster one moves through space, the more slowly one moves through time relative to others. Time is no longer universal. It is deeply personal. The block universe theory offers an even more enduring perspective. In this view, past, present, and future coexist, like a loaf of bread already baked in its entirety. No moment is ever truly lost. Every laugh, every sorrow, every breath you take right now is permanently inscribed within the vast structure of space-time. Time does not flow forward. It simply exists. And death, perhaps, is not an ending, but a shift in consciousness as it glides through these eternal layers. the arrow of disintegration, entropy, and the cost of life. Yet one question remains: why do we experience time only moving forward? Why can we remember the past, but never the future? The answer lies in a single, unyielding law of nature, the second law of thermodynamics. It gives time its arrow. In the physical universe, time reveals itself through entropy, the gradual increase of disorder. The universe began in an extraordinarily orderly state, and ever since, it has been drifting toward chaos. An egg may fall and shatter, but it never gathers itself back together. Time, in this sense, measures decay. It reminds us that all things are finite. Even the brightest stars will exhaust their fuel and fade into silent remnants, white dwarfs, neutron stars, or lonely black holes. And yet, within this truth lies something precious. Because time never returns, because entropy always rises, every moment of order becomes a quiet miracle. Human life itself is such a moment, brief, delicate, and astonishing. We are travelers moving across the surface of disintegration, creating meaning while we can, before all differences dissolve into uniformity. Final horizons, when time grows silent. Looking far into the future, we glimpse endings where time itself may lose meaning. The universe is expanding ever faster, driven by the mysterious force we call dark energy. In the most widely accepted scenario, known as the Big Freeze or heat death, trillions of years from now, all stars will have burned out. Star formation will cease as cosmic gas is exhausted. Even black holes will eventually evaporate. The universe will reach maximum entropy, a state of perfect uniformity. In a cosmos without change or events, time will no longer have a role. It will fade into an eternal, silent darkness. Other possibilities exist. In the Big Rip, dark energy could grow so powerful that it tears apart galaxies, stars, planets, and even atoms, ending time itself in a final rupture of space-time. In the Big Crunch, gravity could reverse expansion, drawing everything back into a singular point where time might end as it began, perhaps only to start anew in another cycle. Whatever the ending, time will have fulfilled its purpose, to serve as the stage upon which matter learned to think and consciousness learned to wonder. The last whisper and rest. Now, as your thoughts return from billions of years in the past and future, allow them to settle gently. The ultimate meaning of time is not found in numbers or clocks, but in its quiet ability to shape beauty within limits. Time gives us a past to remember, a present to cherish, and a future to imagine. No matter the fate of the universe, this peaceful moment you are experiencing tonight is forever part of space-time's structure. You are made of stardust, and time has guided you, from the hearts of ancient stars to this calm, resting breath. Imagine time as a warm, drifting mist surrounding you. The past has finished its weaving. The present holds you gently. The future waits in silence. There is nothing to fear in the passage of time, for in its great river, you have existed, you have felt, and that can never be erased. The universe remains vast, quiet, and compassionate. Galaxies drift slowly. Stars whisper their ancient rhythms. Let your breathing fall into harmony with that rhythm. Release every remaining tension. Allow your mind to drift freely into the deep, endless ocean of space and time. We often believe we understand time completely. We glance at clocks, count the passing seconds, worry about deadlines, or drift back into distant memories. Yet, if we gently peel away the cold precision of those numbers, what remains is not certainty, but a deep and quiet abyss of questions. What is time, truly? And what meaning does it hold for the existence of the entire universe? Let your thoughts wander slowly, without urgency, for tonight we have all the time in the world. You are resting in a small, fragile slice of reality, and yet Allow your mind to follow the ancient reflections of Saint Augustine, who once confessed that when no one asked him about time, he understood it perfectly. But the moment he tried to explain it, it slipped beyond his grasp. In our everyday understanding, time is the steady unfolding of existence, an irreversible progression from past to present to future, the silent heartbeat behind all physical change and human experience. But is time truly a flowing river, or could it be a persistent illusion shaped by the mind itself? For thousands of years, as ancient peoples gazed at the sky and watched the stars return in eternal cycles, they sensed time through the rhythm of seasons and celestial motion. In the philosophies of the ancient East, time was not a straight line stretching endlessly forward, but a vast wheel, Kalachakra, turning through cycles of birth, existence, and destruction, lasting billions of years. In that vision, every ending carried the promise of renewal, a quiet comfort in a world of impermanence. By contrast, the Abrahamic traditions imagined time as an arrow, a linear journey beginning with a divine act of creation and moving inexorably toward a final conclusion. From these differing visions arose humanity's first great debates about time itself. Sir Isaac Newton imagined time as an absolute container, a universal clock set in motion by God, ticking steadily and indifferently, regardless of what occurred within it. Gottfried Leibniz rejected this idea, arguing that time was not a thing at all, but merely a web of relationships between events. Remove the events, and time would lose all meaning. Then came Immanuel Kant, who carried time inward into the human mind itself, describing it as an inborn framework, a lens through which all experience must pass. Without it, he believed, reality would dissolve into chaos. The story of time entered a far stranger and more wondrous chapter in 1905, when a young Albert Einstein sat quietly in a patent office in Bern. Through simple yet profound thought experiments involving light, he shattered Newton's vision of absolute time. Einstein realized that if the speed of light were truly constant throughout the universe, then time itself could no longer remain rigid. It had to become elastic. Time was no longer a fixed stage on which events unfolded, but merged with space into a single, intricate fabric known as space-time. Imagine yourself riding a wave across this fabric of reality. The faster you move, the more slowly your clock ticks compared to someone standing still on the shore. This is not an illusion of perception, but a fundamental truth of the universe. An astronaut traveling at near light speed would return younger than a twin who remained on Earth. Gravity, too, bends time. Near massive objects, such as black holes, time stretches so severely that, to an outside observer, it appears almost frozen at the edge of the unknown. Time itself entered the universe in a violent moment, some 13.8 billion years ago, the Big Bang. This was not merely the birth of matter, but the birth of space and time together. Before that instant, even the idea of before may have had no meaning at all. From that moment onward, time became a silent architect. It allowed energy to condense into matter, and after 380,000 years, when the universe cooled enough to become transparent, it permitted the first atoms to form. When you look at the night sky, you are not seeing the universe as it is now, but as it once was. Every beam of starlight is a traveler from the past, a tiny time machine crossing billions of years to reach your eyes. Even within our own Milky Way, time moves in vast, majestic rhythms. The sun requires roughly 230 million years to complete a single orbit around the galactic center, a span we call a galactic year. Since its birth, it has completed only a handful of these rotations, making all of human history feel like a brief sigh in the life of the stars. Yet in our daily lives, time feels deeply personal and strangely subjective. The human brain does not process reality instantaneously. Sensory signals require about 1/10 of a second to be interpreted, meaning we are always living slightly behind the present. What we call now is actually a small window, about 2 or 3 seconds, during which the brain gathers scattered sensations into a single, coherent moment. As we grow older, time seems to accelerate, perhaps because each year becomes a smaller fraction of our lived experience, or because fewer moments feel new enough to be etched deeply into memory. Some physicists have proposed a concept that challenges all intuition: the block universe. In this view, past, present, and future coexist simultaneously, like slices of a loaf of bread already baked in its entirety. Every moment of your life, your first breath, your joys, your sorrows, and your peaceful rest tonight, exists at a fixed coordinate within 4-dimensional space-time. The feeling that time flows is not a property of the universe, but a creation of consciousness as it moves through these moments. Why then do we only move forward? Why does a shattered egg never return to wholeness? The answer lies in the arrow of time and the second law of thermodynamics. In an isolated system, disorder, entropy, always increases. Time, in its physical essence, marks the transition from order to chaos. The universe began in an extraordinarily ordered state, and since then, it has been slowly unraveling toward disintegration. And yet, this is where time reveals its deepest meaning. Because entropy rises and time never turns back, every moment of order becomes precious. Life, awareness, love, and thought are fragile islands of structure in a growing ocean of chaos. Their very impermanence is what gives them beauty. In the distant future, time whispers of final endings. Driven by dark energy, the universe continues to expand faster and faster. Trillions of years from now, stars will fade, black holes will evaporate, and entropy will reach its maximum in a silent state known as thermal death. When nothing changes, time itself will lose meaning and drift into endless stillness. But before that final quiet arrives, remember this: you are part of the great flow. The atoms within your body were forged in ancient stars, and time carried them across the cosmos to shape your existence. Now, let thoughts of curved space-time and distant galaxies gently dissolve into the night. Time is not a harsh ruler pressing you forward, but a soft mist surrounding you, guiding you toward rest. The past has finished its weaving. The present holds you gently. The future waits in silence. There is no need to hurry. In this calm river of time, every peaceful moment carries its own quiet eternity. The universe remains vast and still. The stars continue their slow, ancient rhythms. Let your breath fall into harmony with them, and allow time to guide you softly into dreams that drift across space and eternity. Are you still there, night travelers? If you are awake, stay with us a little longer. In the vastness beyond the full reach of the human mind, let us drift gently backward through time, to the moment when human consciousness first lifted its gaze to the night sky and asked, with quiet awe, "What is that dark expanse above us?" Echoes from ancient alluvium and oceans. From the very dawn of civilization, space was never an abstract physical idea. It lived instead within creation myths and epic poems. The first peoples of Mesopotamia and ancient Egypt observed the heavens with deep reverence. To them, the world was not distant or detached, but tangible and intimate. Babylonian astronomers of the 7th century before Christ imagined the world as a flat disk encircled by an endless ocean. In this vision, space was not an infinite emptiness, but a finite and sacred realm, a dwelling place of the gods. Celestial wonders were woven into myth. In the epic Enuma Elish, the luminous band of the Milky Way was not understood as countless stars, but as the severed tail of the primordial sea dragon Tiamat, placed across the heavens by the god Marduk after her defeat. Across the seas, in the imagination of ancient Egypt, the sky became the living body of the goddess Nut. arching protectively over the earth. Each evening she swallowed the sun, and each morning she gave birth to it anew. Space, in this vision, breathed with life, an eternal cycle of death and rebirth. These early perspectives reveal something profound. Ancient humans did not see space as cold or soulless. They sensed within it order, intention, and a deep connection to human existence. When space blends with time, the Pacha Symphony. Now imagine yourself standing high in the mist-laden Andes alongside the ancient Incas. Here, space takes on an entirely different meaning. For the Incas, place and moment could not be separated. They were united by a single word, Pacha. In this worldview, space could not exist without time, nor time without space. Pacha described the universe as a living process, an indivisible whole in constant motion. It was a remarkably advanced understanding, one that quietly foreshadowed the idea of space-time that would only be formalized by Einstein centuries later. To the Incas, space was not emptiness, but relationship. Even the dark cloud constellations, those starless voids within the Milky Way, were as meaningful as the points of light, shaping both spiritual understanding and agricultural life. Debates in the shadow of Athens. The story of space entered a new phase of reflection when Greek philosophers began to question the nature of reality itself. No longer satisfied with myth alone, they sought the arche, the fundamental substance from which all things arise. Thales named water. Anaximenes chose air. But Anaximander ventured further, proposing the apeiron, an infinite, undefined source beyond all ordinary elements. With this idea, humanity took its first step toward imagining boundless space. A deeper question soon followed. Can a true void exist? Aristotle, whose influence would dominate Western thought for nearly 15 centuries, answered decisively. Nature, he declared, abhors a vacuum. For Aristotle, space could never be empty. He defined topos as the fixed boundary surrounding an object. Remove all matter, and space itself would vanish. In his universe, every element had its proper place. Earth and water moved downward toward the center. Fire and air rose upward. Space became a structured hierarchy, with a motionless Earth at its heart. Standing in quiet opposition were the atomists, Democritus and Leucippus. They proposed that the universe was composed of indivisible atoms moving through a void. This radical idea introduced emptiness not as absence, but as necessity. Without the void, motion would be impossible, and change itself would cease. Plato, in his dialogue Timaeus, offered a more poetic vision. He called space Chora, the nurse of becoming. To Plato, space was neither matter nor form, but a subtle intermediary, an invisible receptacle that allowed ideal forms to take shape in the material world. It was like soft clay, ready to receive whatever form the cosmos impressed upon it. Insights from the darkness of the East. While Western thinkers debated containers and boundaries, Eastern philosophies were already contemplating infinity. In ancient China, the astronomer Zhang Heng believed space extended far beyond the visible stars. The Xuan-Ye school described the heavens as boundless, empty, and without substance. The sun, moon, and stars, they said, floated freely, unsupported, unanchored, moving through space with natural ease. This vision stood in stark contrast to the rigid crystalline spheres imagined by the Greeks. In India, ancient Vedic texts spoke of a universe unfolding through endless cycles of creation and dissolution. Space was associated with Akasha, the most subtle element, permeating all things and carrying the vibrations of existence itself. A subtle distinction: the lens and the light. As observation tools improved, humanity's view of space slowly shifted toward measurement and geometry. Yet echoes of myth remained. Even Galileo Galilei, who used the telescope to discover the moons of Jupiter, Sometimes believed the faint glow of the Milky Way resulted from atmospheric effects. Still, Galileo dealt a decisive blow to the Aristotelian universe. He recognized that circular motion could be natural and that space need not obey a rigid hierarchy. René Descartes followed, envisioning space as infinite, uniform, and governed by Euclidean geometry. Though he denied the existence of a true vacuum and considered space merely an extension of matter, Descartes moved humanity closer to a mathematical conception of reality. Now, let us return to the 17th century, an age when reason began to illuminate the universe's darkest corners. Tonight, I invite you to witness a classic intellectual confrontation, a quiet yet monumental struggle between two towering minds. It is the story of space itself. Is it an absolute container or merely a web of relationships? Picture yourself in an ancient library. Candlelight flickers, casting long shadows across heavy volumes of ink and parchment. Here, two giants prepare for a battle of ideas whose echoes will resound for centuries. On one side stands Sir Isaac Newton, England's brilliant son, the architect of classical physics. On the other, Gottfried Wilhelm Leibniz, the German polymath whose mind crossed cultures and disciplines. Newton's first foundations, the eternal container. Newton gazed at the heavens and perceived absolute order. For him, space was no vague abstraction. He imagined the universe as a vast, rigid, and unchanging stage, absolute space. Even if God were to remove every star, every planet, every particle of matter, Newton believed this infinite container would remain, silent and eternal. In his view, space existed independently of the objects within it. It was a real entity, even a kind of divine sensorium in which all motion unfolded according to precise laws. To demonstrate that absolute space was more than illusion, Newton proposed a simple yet profound thought experiment: the spinning bucket. Imagine in the surrounding darkness a bucket filled with water, suspended by a twisted rope. At first, everything is still. The water's surface lies flat and calm. Release the bucket, and it begins to spin. The water lags behind, remaining flat until motion is gradually transferred. Then the surface curves inward, rising at the edges. Newton asked a haunting question: what is the water rotating against? Even when the bucket slows and stops, the water continues to spin, its surface still curved. This, Newton argued, could not be explained by motion relative to the bucket alone. The water, he concluded, must be rotating relative to absolute space itself. For nearly 2 centuries, this spinning bucket stood as a quiet sentinel, guarding the belief that space exists as a real and rigid entity beyond all things. Leibniz's mirror reflection, a web of relationships. But across the English Channel, Gottfried Wilhelm Leibniz regarded the idea of an empty cosmic container with a quiet smile. To Leibniz, space was not a material thing, nor an independent substance floating behind reality. Without matter, he believed, space was nothing at all. He called this view relational space. Let your thoughts follow the calm logic of Leibniz for a moment. He compared space to the relationships within a family. There is a father, a mother, children, but the relationships between them exist only because the people themselves exist. Remove the people, and the very ideas of parent or sibling vanish. In the same way, Leibniz argued, space is simply the order in which objects coexist. It is not a thing in itself, but a pattern formed by the presence of things. To challenge Newton, Leibniz wielded a sharp philosophical tool: the principle of sufficient reason and the identity of indiscernibles. He asked Newton to imagine 2 universes that are perfectly identical in every measurable way, except that in the second universe, everything has been shifted 5 feet to the left in absolute space. Leibniz posed a simple yet devastating question: how could we ever tell the difference? If no observation could distinguish between them, then, he argued, the two universes are in fact the same. God would have no reason to place the universe here rather than there, since all positions in absolute space would be indistinguishable. From this, Leibniz concluded that absolute space was an unnecessary and incoherent idea. Space, he said, is nothing more than the name we give to the relationships between objects. The debate became a hall of mirrors. Where Newton saw a solid, invisible foundation, Leibniz saw only a web of interwoven connections. Their arguments unfolded in intense correspondence with Samuel Clarke, Newton's defender. The dispute did not truly end. It merely fell silent with Leibniz's death in 1716. For generations afterward, Newton's vision of space would reign unchallenged. Kant and Mach, when the stage begins to tremble. Time passed, slowly, steadily, like the rhythm of your breathing. Then in the 18th century, Immanuel Kant entered the conversation and quietly overturned the board. Kant did not ask whether space existed out there, as Newton believed, or whether it was merely relational, as Leibniz proposed. Instead, he brought space inward, into the human mind. Kant declared that space is a form of intuition, something given a priori. Imagine wearing a pair of glasses that you can never remove. Every scene you witness is filtered through them. Space, for Kant, functions in exactly this way. It is not learned from experience. Rather, it is the pre-existing framework that allows experience itself to be organized. Without this inner spatial structure, the world would dissolve into an unrecognizable blur of sensations. In the 19th century, another challenge arose, this time from physics. Ernst Mach delivered a serious blow to Newton's famous spinning bucket. Mach agreed with Leibniz that all motion must be relative. He proposed that the curved surface of the spinning water was not caused by rotation relative to absolute space, but by rotation relative to the mass of the entire universe, especially the distant stars. Mach suggested something radical. If the bucket existed in an otherwise empty universe, with no stars or galaxies beyond it, the water's surface would remain flat, no matter how fast it spun. This idea, later called Mach's principle, would linger quietly in the background, waiting for a young thinker who was about to change everything. Einstein's Final Symphony, when the stage joins the dance. Then came Albert Einstein in 1905 and again in 1915, lifting the veil to reveal a universe more subtle and beautiful than either Newton or Leibniz had imagined. Einstein realized that space cannot be separated from time. He fused them into a single four-dimensional entity, space-time. With his general theory of relativity, the centuries-old debate was finally transformed. Space, Einstein showed, is neither a rigid, empty container nor a purely abstract web of relations. Instead, space is a physical entity, flexible, dynamic, and responsive. Picture it as a vast silk carpet. Place a heavy sphere upon it, and the fabric curves. What we experience as gravity is no longer an invisible force pulling objects together, but the bending of space-time itself. In this synthesis, both Newton and Leibniz were partially right and partially wrong. Newton was correct in believing that space has objective properties, but mistaken in thinking it was unchanging. Leibniz was right to insist on the deep connection between matter and space, but wrong to deny space any physical reality. Einstein united them. Space-time tells matter how to move, and matter tells space-time how to bend. The stage and the actors have become one, locked in an eternal dance. Today, we know that space is stranger still. Edwin Hubble revealed that space itself is expanding. Galaxies are not rushing through a static arena. Rather, the space between them is continuously being created. The universe began in a singular moment, the Big Bang, when space and time were born together. From Newton's absolute container, Through Leibniz's network of relations to Einstein's living tapestry, humanity has traveled far in understanding where it exists. Space is like an endless silken ocean. Matter forms the islands that ripple its surface, shaping currents that carry stars toward unseen horizons. And you, too, are part of that ocean, gently held within the curves of reality. We have listened to the debates of great minds, and through them, our understanding of space has deepened. Now, night travelers, let your thoughts lift gently from the ground, drift beyond the thinning atmosphere. Enter the silent canyons between stars and the vast, dark oceans between galaxies. For this is not an empty void. It is a living, structured presence, quietly breathing, endlessly stretching, filled with wonders waiting to meet you in the calm of your sleep. The journey from home, the boundary of nothingness. Our story begins as you rise gently above the clouds, beyond the familiar paths of birds and jet aircraft. Higher still, at an altitude of roughly 100 kilometers, you reach an invisible yet decisive threshold, the Kármán line. Here, the atmosphere becomes too thin to support wings, and the language of aerodynamics quietly yields to the rules of spaceflight. Crossing this boundary, space is no longer an abstract idea from textbooks. It reveals itself as a stark yet pristine environment, a near-perfect vacuum where friction all but disappears. In this silence, planets and satellites can glide along their orbits for billions of years without slowing. Yet do not mistake stillness for emptiness. Space is permeated by a faint, unseen presence. Drifting dust particles, high-energy cosmic rays, elusive neutrinos, and vast magnetic fields stretched like delicate spiderwebs across the void. Space even carries a subtle signature of its own. Astronauts returning from spacewalks often describe a sharp, metallic scent clinging to their suits, reminiscent of burnt metal or welding fumes, a trace left by oxygen atoms interacting with equipment as it floats in low Earth orbit. Geospace and cislunar space, our familiar neighborhood. The first region of space to cradle our planet is known as geospace. This is where the Van Allen radiation belts reside, vast donut-shaped zones encircling Earth's equator, trapping energetic particles carried by the solar wind. Drift a little farther, and you enter the cislunar region, the quiet expanse between Earth and the Moon. Here, space behaves like a vast mirror. When you glimpse the dark portion of a crescent moon faintly glowing, you are seeing Earthlight, sunlight reflected from our blue planet, touching the lunar surface and returning gently to your eyes. In this realm, space becomes an invisible thread of balance. Earth's gravity still reigns, sculpting special locations known as Lagrange points, places of near-perfect equilibrium where gravitational forces cancel each other out. It is in such serene pockets of space that observatories like the James Webb Space Telescope can rest, almost effortlessly, gazing into the depths of time. Interplanetary space, within the breath of the sun. Leaving the Earth-Moon system behind, you enter interplanetary space. Here, space is no longer still. It is alive with the solar wind, a constant stream of charged particles flowing outward from the sun at millions of kilometers per hour. This entire domain is enclosed within a vast protective bubble called the heliosphere. It shields the planets from the harsher cosmic radiation drifting in from beyond our galaxy. Within this bubble lie invisible boundaries, sometimes called soot lines and frost lines. Close to the sun, space is too warm for volatile substances to survive. Only rock and metal can gather, forming worlds like Earth. Farther out, beyond the frost line near Jupiter, temperatures drop low enough for ice to persist, giving rise to gas giants and frozen worlds rich in hydrogen and methane. Under the dim glow of the planets, you may notice a faint triangular band of light stretching along the night sky, the zodiacal light. This gentle glow is sunlight scattered by countless microscopic dust grains, the quiet remnants of ancient asteroid collisions and wandering comets. Interstellar space, the eternal frontier. Approaching the outskirts of the solar system, roughly 120 astronomical units from its center, the solar wind begins to weaken. Here it meets resistance from the galactic environment. This distant boundary is known as the heliopause, the final edge of our cosmic home. Beyond it, you officially enter interstellar space. Do not imagine a lifeless desert. Interstellar space is threaded with immense clouds of gas and dust, vast beyond comprehension. Some are cold molecular clouds, stellar nurseries where matter gathers slowly under gravity, giving birth to new suns. Within this apparent emptiness, scientists have detected complex organic molecules, even simple alcohols suspended quietly in the cold gas, assembling the earliest ingredients of life. In this region, space itself is no longer flat. As Einstein taught us, every massive star bends the space around it, much like a heavy sphere placed upon a stretched fabric. The straight paths we imagine are, in truth, gentle curves shaped by mass and energy. Intergalactic space, the greatest deserts of reality. Our journey now expands to its grandest scale, intergalactic space. This immense realm occupies most of the universe's volume, stretching between luminous islands of galaxies. On this scale, the universe resembles a vast cosmic web. Galaxies are not scattered randomly, but arranged along colossal filaments, hundreds of millions of light years long, bound together by the unseen framework of dark matter. Between these glowing strands lie cosmic voids, enormous regions where almost nothing exists at all. Here, one of the universe's strangest truths becomes clear. Space itself is expanding. Galaxies are not simply drifting through a fixed backdrop. Rather, the space between them is continuously growing. Imagine ink dots on the surface of an inflating balloon. The dots move apart, not because they are traveling, but because the surface itself is stretching. Driving this expansion is dark energy, a mysterious presence accounting for nearly 68% of the universe. It fills space uniformly, and unlike matter, it does not thin out as space grows. Instead, the more space there is, the stronger its influence becomes, quietly urging the universe toward an ever more diluted future. Space as a block universe, the permanence of every moment. And now, the deepest secret of space itself. Some physicists propose a vision known as the block universe. In this view, space and time are not flowing rivers, but a single, eternal, four-dimensional structure where every event, past, present, and future, exists at a fixed coordinate. Within this vast block of reality, your home on Earth, the slow rotation of the Milky Way, and the very moment you are lying here, preparing for sleep, are all permanently inscribed. Space is not merely a place you occupy. It is a woven tapestry holding the entire story of existence, quiet, complete, and everlasting. Now, night travelers, we arrive at the hand of the silent builder, its quiet influence in shaping the universe. This is the story of how space, so often mistaken for a soulless void, has always been, and will forever remain, the greatest architect of reality, silently shaping every corner of the cosmos you inhabit. Prelude, when nothingness begins to speak. For thousands of years, humanity believed that space was merely a mute stage, an empty container waiting patiently to be filled with matter. Yet at the dawn of the 20th century, when the veil of reality was gently lifted, we were confronted with a profound truth. Space is anything but passive. It is a living physical entity, a four-dimensional structure inseparably woven with time, forming a single continuous fabric, space-time. Our universe did not begin within space, because space itself was born in that same primordial moment, roughly 13.8 billion years ago. Before then, even the idea of before may have had no meaning, for time did not yet exist. From an unimaginably hot and dense singularity, space emerged, not as an explosion flinging matter into emptiness, but as the rapid expansion of the very structure of reality itself. The builder of the past, the push toward flatness. Imagine witnessing the universe in its very first heartbeat. In an almost immeasurable instant, between 10 to the power of minus 36 and 10 to the power of minus 32 seconds after the Big Bang, a process known as inflation took place. In that fleeting moment, space expanded by a factor of at least 10 to the power of 26. This extraordinary surge shaped the universe we observe today. Tiny quantum fluctuations, imperceptible ripples in density, were stretched into the vast cosmic structures that would later become galaxies and clusters. Without this sudden expansion, the universe might never have achieved the remarkable flatness and uniformity we now measure. In this earliest era, space acted as a rough yet masterful builder, smoothing the initial chaos and preparing the foundation for a stable cosmos. As space continued to expand and cool, it created room for complexity to emerge. After about 380,000 years, the universe had grown calm enough for protons and electrons to unite, forming neutral hydrogen atoms in an event known as recombination. In that moment, space transformed from a dense, opaque fog into a transparent expanse. Light was finally free to travel. Those first wandering photons still surround us today as the cosmic microwave background, a faint afterglow that preserves the universe's original blueprint. The builder of the present, the dance of curves. Now let your breathing settle into harmony with the slow rotation of the Milky Way. In the universe as it exists today, space is far more than a backdrop for stars. It actively governs their motion. Albert Einstein revealed this profound truth in a single sentence. Space-time tells matter how to move. Matter tells space-time how to bend. Gravity, once imagined by Newton as an invisible force, is in fact the natural consequence of matter and energy curving the structure of space itself. Picture space as a soft, yielding surface. Place a massive star upon it, and the surface dips gently, guiding planets along curved paths they cannot escape. Space reveals itself across many scales. Interplanetary space, where the solar wind streams outward, enclosing our solar system within a vast protective bubble known as the heliosphere. Interstellar space, seemingly empty yet filled with dust, radiation, and immense clouds of gas that rely on space-time's subtle curvature to collapse and ignite new stars. Intergalactic space, the greatest deserts of reality, where matter is so scarce that only a handful of atoms drift through each cubic meter. Most astonishing of all, space continues to expand with every passing second. Distant galaxies recede not because they are racing through space, but because new space is constantly being created between them. This expansion is measured by the Hubble constant, a key that allows us to estimate the age and scale of the universe itself. Space also works hand in hand with an unseen partner, dark matter. Though invisible, it permeates space, forming an underlying skeleton that guides galaxies into vast filaments, shaping the universe into a structure resembling a cosmic web or sponge. The builder of the future, the final whispers. As we turn our gaze toward the distant future, the silent hand of space continues its work. About 5 billion years ago, a mysterious influence began to dominate the universe: dark energy. Unlike matter, it does not clump or condense. It exists uniformly throughout space, exerting a subtle but relentless repulsive force. Because of dark energy, the expansion of space is not slowing down, it is accelerating. From this, several haunting possibilities emerge. In the scenario known as heat death, or the Big Freeze, space continues to expand forever. Matter becomes increasingly diluted. Trillions of years from now, stars will fade, black holes will evaporate, and entropy will reach its maximum. the universe will settle into a cold, silent ocean where no change occurs and time itself loses meaning. In the Big Rip scenario, if dark energy grows stronger with time, space will expand so violently that it tears apart galaxies, solar systems, and ultimately even atoms. The very fabric of space would be undone. And finally, though less likely, the Big Crunch envisions a reversal. If matter were somehow to overcome dark energy, expansion would halt, and space would collapse back into a singularity, echoing the universe's beginning. Take a long, unhurried breath. Feel the cool air gently fill your lungs, then release it slowly, allowing the weight of the long day to drift away. You are resting now, safe, still. While beyond your walls, the vast universe continues its ancient rhythms, unseen by the naked eye, yet always present. Tonight, I invite you on a journey not of distance, but of thought. We will travel backward, far beyond memory, toward the very beginning of everything, the Big Bang, and the quiet birth of the eternal twins. There is no need to hurry. The night is wide, and time is generous. Together, we will contemplate the moment 13.8 billion years ago, when space and time were not waiting in the darkness, but emerged together, inseparable, out of nothingness itself. Let my voice be your calm companion as we drift gently toward understanding, and perhaps toward sleep. On the threshold of existence, imagine standing at the edge of a reality where the idea of a place has not yet formed. In this profound silence, we search for the oldest questions humanity has ever asked. How was the universe born? And where did we come from? Everything began roughly 13.8 billion years ago. At that instant, the entire universe as we know it today, all galaxies, all stars, and even you, was compressed into an unimaginably hot and dense state. Scientists call this beginning a singularity. Allow your mind to rest on this image. The singularity is not a glowing sphere suspended in darkness. It is an infinitely small mathematical point where density and temperature reach infinity, and where the laws of physics, as we understand them, quietly dissolve. The most important thing to remember as you listen tonight is this. The Big Bang was not an explosion that happened inside space. It was the moment when space and time themselves came into being. Many people ask what existed before the Big Bang, or where in space it occurred. Yet through the lens of general relativity, such questions may gently mislead us. If time itself began at that moment, then the notion of before may have no meaning at all. And since space was born alongside time, there was no external emptiness for the universe to expand into. The Big Bang was not movement through space. It was the expansion of space itself, the Planck era, and the first beat of time. Now let your awareness drift softly into the universe's earliest instant, the first 10 to the power of minus 43 seconds. This fleeting interval is known as the Planck era. In this almost inconceivably brief moment, the universe is smaller than an atom. It is a time of absolute unity. The four fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, are bound together as one. At this scale, gravity behaves in ways we do not yet fully understand, and our current theories fall silent. Space at this moment is neither smooth nor calm. It resembles a restless foam, trembling with the earliest hints of reality. And here, time begins its very first pulse. The emergence of the twins, space and time, lays the foundation for the four-dimensional fabric we call space-time. Picture time as a thread and space as a loom. During the Planck era, the first thread slips quietly into place, and the loom begins to move. Time gives order to events, while space provides the stage upon which they unfold. As the universe cools from temperatures exceeding 10 to the power of 32 degrees Celsius, this perfect unity begins to separate. gravity is the first to step away, quietly assuming its role as the universe's great sculptor. Inflation, when space grows faster than light. As your breathing settles into a steady rhythm, let us witness one of the most astonishing chapters in cosmic history: inflation. Around 10 to the power of minus 36 seconds after the beginning, the universe entered a phase of extraordinarily rapid expansion. In far less than a trillionth of a second, space itself expanded faster than light, not violating the laws of physics, but redefining scale itself. A region once smaller than a proton ballooned to a size at least 10 to the power of 26 times larger. This moment was crucial for the twins. For space, inflation smoothed away its initial roughness and curvature, giving rise to the remarkably flat universe we observe today. Matter and energy were spread evenly, setting the stage for cosmic order. For time, inflation preserved the tiniest quantum fluctuations, minute ripples in energy density. Stretched across vast distances, these fluctuations became the seeds from which gravity would later build galaxies and clusters of unimaginable size. By about 10 to the power of minus 32 seconds, inflation gently came to an end, leaving behind a universe rich with energy and promise. Space was no longer a point. It had become a grand stage, waiting for its story to unfold. The first minutes and the arrow of disintegration. With inflation complete, the universe entered a phase known as reheating. Energy released from the inflationary field flooded space, filling it with an intense sea of elementary particles, a quark-gluon soup glowing with heat. Between 2 and 20 minutes after the Big Bang, a vital process called nucleosynthesis took place. During this short window, conditions allowed nuclear reactions to form the first atomic nuclei: hydrogen, helium, and traces of lithium. Here, the arrow of time reveals itself with clarity. Time is not merely a way to count moments, it carries direction. The second law of thermodynamics tells us that entropy always increases. The universe began in a state of extraordinary order, and it is this imbalance that drives time forward, ensuring that broken eggs do not reassemble and starlight never returns to its source. In this era, space and time work in perfect partnership. Space expands, allowing the universe to cool. Time flows forward, permitting events to unfold in an irreversible sequence. Without the expansion of space, the universe would have remained a blazing furnace, and life would never have found a foothold. The first light and the eternal blueprint. Now, let us move gently forward to a time 380,000 years after the beginning. The universe has cooled enough for electrons to bind with atomic nuclei, forming the first neutral atoms. This moment is known as recombination. Until then, the universe was opaque, like a dense fog that trapped light. But with the birth of atoms, space suddenly became transparent. Light was finally free. These first photons began a journey that continues even now, reaching us as the cosmic microwave background. This faint glow is the universe's earliest record, a quiet echo preserving the combined work of space and time. When scientists study the CMB, they find a universe that is flat, gently patterned with tiny temperature variations, clear fingerprints of inflation. It is among the strongest evidence that space and time truly share a common origin. Space and time are like the two wings of a great eagle. The Big Bang is the moment that eagle spread its wings and lifted itself from the peak of nothingness. One wing, space, extends outward, offering room for all things to exist. The other, time, beats steadily, allowing the universe's story to unfold. Without either wing, reality itself would never have taken flight. After witnessing the magnificent birth of space and time, let us drift gently into a deeper chapter, one where the ideas of somewhere and sometime are no longer separate. Welcome to the Space-Time Symphony, where the actors and the stage quietly become one. In this calm moment, allow your thoughts to float among the stars. Here, we will contemplate a strange and beautiful reality called space-time. There is no need to hurry. In this realm, time follows its own rhythm, and space yields softly to motion and thought alike. Let my voice guide you, slowly, into the universe as Einstein once glimpsed it. A universe where the stage itself joins the performance, forming an endless cosmic symphony. The collapse of the absolute container. Before Einstein, humanity rested within a comforting illusion of certainty. Sir Isaac Newton, the great architect of classical physics, imagined space as a vast, rigid, and eternal container. In his vision, space existed independently of the matter within it. Even if every star were removed, space would remain, silent, unmoving, unchanged. Time, too, flowed absolutely, ticking forward like a divine instrument, untouched by the events it measured. Yet this stillness was deceptive. Imagine yourself lying on a small boat drifting across a quiet lake at night. Without watching the shoreline, you would feel perfectly motionless, even as the water carries you onward. Galileo understood that motion is always relative, but it was Einstein who dared to remove the final veil. He realized that if the speed of light were truly constant for all observers, as experiments had confirmed, then space and time could no longer remain rigid. They had to bend, to adapt, to become flexible. The magnificent unification, Minkowski's declaration. In 1908, 3 years after Einstein introduced special relativity, his former teacher Hermann Minkowski made a statement that reshaped our understanding of reality. From now on, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Minkowski revealed that we do not live in a world of 3 dimensions plus time, but within a single 4-dimensional structure known as space-time. Here, left and right, up and down, forward and back, are woven together with past and future, like threads in an immense tapestry. Think of a simple event in your life, the moment you are listening to these words. To describe it fully, you need 4 coordinates. 3 to locate you in space, and 1 to locate you in time. In space-time, you are not only where you are also when you are. Every object in the universe, from an atom in your breath to a distant galaxy, traces its own unique path through this structure. Physicists call this path a world line, the stretch of reality, when space and time transform. Space-time, however, is not a rigid scaffold. It stretches and reshapes itself according to motion. Time dilation. In this 4-dimensional universe, motion through space trades directly with motion through time. Imagine that nature grants every object a fixed budget, equal to the speed of light. When you are at rest, all of that motion carries you forward through time, and your clock ticks normally. But as you move faster through space, some of that budget is diverted. Time slows for you compared to someone at rest. This is no illusion. Astronauts aboard the International Space Station age slightly more slowly than those on Earth, and particles traveling near light speed survive far longer than they otherwise would. Length contraction. At the same time, space itself responds. The faster an object moves, the more space contracts along its direction of motion. A ruler 1 meter long, traveling near the speed of light, would appear compressed to a thin slice. Space and time perform a delicate balancing act, preserving the constant speed of light. The invariant space-time interval. Observers moving differently may disagree on distances and durations, but there is one quantity they all share: the space-time interval. This is the quiet heartbeat of space-time itself. In ordinary geometry, distance is found using the Pythagorean theorem. In space-time, a similar equation applies, but with a crucial minus sign linking time and space. This subtle difference gives rise to the light cone, defining the ultimate boundary of cause and effect in the universe. The block universe, where past, present, and future coexist. When space-time is accepted as a unified whole, an unsettling idea emerges: the block universe. Imagine the entire history of the universe as a massive loaf of bread. Each slice represents a moment we call now. But because motion affects time, different observers slice this loaf at different angles. Your present may include events that, for someone else, belong to the past or the future. If another person's now can overlap with what you call your past, then the past cannot simply vanish. It must exist, quietly, within the four-dimensional structure of space-time. In this view, time does not truly flow. Instead, our consciousness moves along a fixed landscape of events. Every joy of your childhood, every sorrow you have known, and even this gentle moment of rest are permanently inscribed within the universe. Einstein once expressed this thought with calm tenderness. For those of us who believe in physics, the distinction between past, present, and future is only a stubborn illusion. When the stage bends, the nature of gravity. Our journey now reaches its most poetic revelation. In 1915, Einstein understood that space-time is not merely the setting of events. It is an active participant. Here, the actor and the stage finally become one. Gravity is no longer a mysterious force pulling objects together. It is the curvature of space-time itself. Picture space-time as a soft mattress. Place a heavy sphere upon it, and the surface bends. A smaller object nearby does not feel a pull. It simply follows the curve that has already been shaped. Physicist John Wheeler captured this truth in a single sentence. Space-time tells matter how to move. Matter tells space-time how to bend. Even now, as you rest, the sensation of weight is the gentle pressure of Earth curving space-time beneath you. This curvature also affects time. Where gravity is stronger, time moves more slowly. Someone living at the base of a skyscraper ages slightly less than someone at the top. Near a black hole, space-time curves so intensely that time itself appears to freeze to a distant observer. Ripples of nothingness, gravitational waves. To complete this symphony, listen closely to space-time's own vibrations. Einstein predicted that violent cosmic events would send ripples through space-time itself, like waves traveling across a stretched fabric. In 2015, exactly 1 century later, humanity finally heard this whisper. The LIGO Observatory detected the faint chirp of 2 black holes colliding 1.3 billion years ago. That distant catastrophe gently stretched and compressed space-time here on Earth by less than the width of a proton, before passing silently onward. These gravitational waves are the final confirmation that space-time is real. It can bend, it can ripple, and it can carry the ancient stories of the stars across the universe, quietly, patiently, forever. After we have traversed the magnificent birth of the universe and listened to the symphony of space and time in earlier chapters, we now arrive at the final quiet threshold of our journey. Tonight, I invite you into a chapter both profound and reflective, the whispers of the galaxy and the future of all things. In this stillness, allow your thoughts to drift gently among the stars. Here, we will reflect on how space-time is not merely a backdrop for existence, but the ultimate measure and silent arbiter of every destiny in the universe. There is no need to hurry. In this realm, time follows its own unhurried rhythm, and space bends softly with each calm breath you take. Our story begins close to home, in the deep darkness we belong to, the Milky Way. Imagine yourself hovering at the edge of a vast, luminous whirlpool, a spiral galaxy nearly 87,400 light-years across. Within it dwell between 100 and 400 billion stars. Among them, our solar system is no more than a modest spark, resting about 27,000 light-years from the galactic center. Even now, as you prepare for sleep, the entire solar system is moving, swiftly and steadily, at about 220 kilometers per second, tracing a long, graceful orbit around the heart of the galaxy. One full revolution takes roughly 230 to 240 million years, a span astronomers call a galactic year. Since humanity first appeared, we have completed only a tiny fraction of this journey. On this scale, time is no longer counted in days or lifetimes, but in the solemn turning of stars. Within the Milky Way, space-time reveals itself as a true physical measure. Turn your attention toward the constellation Sagittarius, where Sagittarius A star resides, a supermassive black hole more than 4 million times the mass of our Sun. Here, space-time is compressed and distorted to an extreme degree. For astronomers, Sagittarius A star is not merely an object, but a cosmic reference point, a living laboratory for testing Einstein's ideas. As matter spirals inward, time slows so dramatically that, to a distant observer, it seems almost frozen. This precise warping of space-time is what allows us to calculate the mass and confirm the existence of these otherwise invisible giants. Space-time, as a unified whole, is the most faithful measure of reality we possess. In everyday experience, space and time appear separate, yet in truth, they are woven together into a four-dimensional tapestry. One of the ways space-time reveals its nature is through light, the only true constant. Light travels at 186,000 miles per second, unwavering and absolute. Because light needs time to cross space, every glance into the night sky is also a glance into the past. Moonlight reaches your eyes after 1.3 seconds. Sunlight arrives after 8 minutes. The glow of distant stars may have traveled for thousands of years. In this way, space-time becomes a vast chronicle, where distance is measured not just in length, but in time itself. Let your breathing slow further as we consider the intimacy of these twin dimensions. Einstein taught us that space-time is not a rigid stage, but a living structure, shaped by matter and energy. Space-time determines how matter moves, and matter determines how space-time bends. This quiet exchange is what we experience as gravity. When you feel the weight of your body resting on the bed, you are sensing the curvature of space-time created by the Earth beneath you. On a far greater scale, this same bending governs the motion of billions of stars, holding the Milky Way together across unimaginable distances. Yet space-time conceals an even more subtle truth: time dilation. The faster an object moves through space, the more slowly it moves through time. An astronaut traveling near the speed of light might experience only a few years, while centuries pass on Earth. Space-time is so flexible that each of us carries a personal clock, shaped by motion and gravity, ticking softly at its own pace. Now, let us turn our gaze toward the future of all things, where space-time determines the ultimate fate of the cosmos. The universe is not still, it is expanding. Edwin Hubble discovered that distant galaxies are moving away from us, and the farther they are, the faster they recede. Even more astonishing, this expansion is accelerating. The force behind it is dark energy, a mysterious presence that accounts for more than 2/3 of the universe's total energy. Dark energy fills space uniformly, gently yet persistently, pushing the universe apart. In this way, it holds the measure of destiny itself. Scientists have outlined 3 principal visions of how space-time may conclude its long work. The first, and most widely supported, is heat death, also known as the Big Freeze. If expansion continues indefinitely, galaxies will drift beyond one another's reach. Trillions of years from now, the last stars will exhaust their fuel and fade. Black holes will remain for a time, but even they will slowly evaporate. As entropy reaches its maximum, change itself will cease. In such a universe, time loses its meaning and settles into an endless, silent rest. The second scenario, more violent in nature, is the Big Rip. If dark energy grows stronger, space may expand so rapidly that it overwhelms every binding force. Galaxies, stars, planets, and eventually atoms themselves would be torn apart until space-time is shredded beyond recognition. The third, more cyclical and contemplative, is the Big Crunch. Should matter one day overcome dark energy, expansion would halt and reverse. The universe would collapse inward, drawing space-time back into a blazing singularity, perhaps setting the stage for another beginning, a renewed cycle known as the Big Bounce. My dear friend, if your mind feels tired after traveling so far, through distant galaxies and distant futures, allow yourself to rest upon the soft fabric of space-time. You are not simply lying in a quiet room. You are a single note within the vast symphony of reality. The atoms in your body were forged in ancient stellar hearts, long before this moment, within this very galaxy. Beyond these walls, the universe continues its gentle expansion, carrying your worries outward into the darkness. Let your heartbeat align with the slow rhythm of the stars. There's nothing left to hold on to. Within this eternal four-dimensional structure, every moment of peace you feel is preserved. The past is complete. The future waits in calm silence, and the present is a steady anchor easing you toward rest. May your dreams be gentle and wide, drifting freely across the dimensions of space and time. Good night, night travelers.